Imagine waking up tomorrow and the world feels off. You flip a light switch and there's a noticeable delay before the room illuminates. You try to call a friend and their voice lags, making conversation impossible. Your internet is so slow it feels like a throwback to the dial-up era. This isn't a dream or a glitch in your devices. This is a world where the fundamental speed limit of the universe, the speed of light, has dramatically slowed down overnight. What would actually happen if CSE, the cosmic constant, suddenly wasn't so constant? Let's explore the mind-bending consequences. First, let's get a handle on what the speed of light, or C, really is. It's not just about how fast light travels. It's the speed of causality itself. It's the fastest that any information, any force, or any object with mass can travel through space. It's woven into the very fabric of space-time. So, messing with it isn't like changing the speed limit on a highway. It's like changing the laws of physics that build the road, the cars, and even you. Let's start with a scenario where the speed of light drops significantly, say, to just a few thousand miles per second. The first thing you'd notice is the lag. The light from the sun, which normally takes about 8 minutes and 20 seconds to reach us, would now take hours. This means your morning would start in darkness, long after the sun has actually risen over the horizon. The sky would be a bizarre, time-delayed canvas. You'd see stars and galaxies, not as they were thousands or millions of years ago, but in a state that is even further back in time. Communication would be a nightmare. Our entire global infrastructure relies on signals traveling at or near the speed of light. Fiber optic cables, satellites, Wi-Fi would be crippled. A video call with someone across the country would have a delay of several seconds, making real-time conversation impossible. International calls? Forget about it. The world would suddenly feel vast and disconnected again, like in the age of sail. Our interconnected global village would shatter into isolated communities. But the weirdness is just getting started. Let's talk about Einstein's famous equation. E equals mc squared. E is energy, m is mass, and c is the speed of light. Notice that c is squared in this equation. This means that a small change in c has a huge impact on the relationship between mass and energy. If the speed of light decreased, c squared would become a much smaller number. This would mean that converting mass into energy would release far less power. Nuclear power plants, which rely on this very principle, would simply stop working. Their reactions wouldn't generate enough energy to sustain themselves, let alone power our cities. The same goes for the sun. The nuclear fusion happening in the sun's core, turning hydrogen into helium, would release drastically less energy. The sun would cool down and dim significantly. It might not go out completely, but it would become a pale, weak version of its former self, plunging Earth into a permanent, frigid twilight. Life as we know it, which depends on the sun's consistent energy, would face an extinctional level event. What about our perception of reality? Strange things would start happening with motion. According to special relativity, as an object approaches the speed of light, its mass increases. Time slows down for it, and it contracts in length. If the speed of light were slow enough, say the speed of a car on a highway, these relativistic effects would become part of our everyday experience. Driving your car would mean you'd actually get slightly heavier. Time would tick slower for you than for someone standing still. Objects would appear visually distorted and squashed in the direction of motion. You could literally see the colors of light shift as things move towards or away from you, a phenomenon known as the relativistic Doppler effect. It would be a surreal, funhouse mirror version of the world. But it gets even more fundamental. The speed of light also governs the strength of electromagnetic forces, the very forces that hold atoms together. The fine structure constant, a number that determines this strength, depends on the speed of light. If c changes, this constant changes. The result? Chemistry itself would break. The bonds that hold molecules together would change. Water might not be H2O anymore. The air we breathe could transform into a different substance. The atoms in your own body could lose their integrity. Essentially, the very matter that makes up you, me, and everything around us could simply fall apart. This isn't just an inconvenience. It's the end of matter as we know it. Okay, so slowing down the speed of light is clearly catastrophic. What if we go the other way? What if the speed of light suddenly increased, becoming, say, 10 times faster or even infinite? If c became infinite, E equals mc squared would mean that mass and energy are infinitely interchangeable. Any speck of dust could release an infinite amount of energy. The universe would instantly vaporize in a blaze of unimaginable power. So, an infinite speed of light is a non-starter. Let's imagine a more modest increase, maybe doubling its current value. Communication would be faster, which sounds great, but the consequences for energy would be terrifying. E equals mc squared tells us that now, converting a tiny amount of mass would release a colossal amount of energy. Far more than before. The sun's fusion reactions would accelerate violently. It would burn hotter and brighter, blasting Earth with lethal radiation and scorching the surface, boiling away the oceans. Nuclear reactions on Earth would become absurdly powerful and unstable, turning our power plants and weapons into ticking time bombs of unimaginable destructive potential. The delicate energy balance of the universe would be thrown into chaos. So, it seems that the speed of light is perfectly tuned. It's not just a random number. It's a foundational pillar of our reality. Any change, whether up or down, would lead to a universe where the laws of physics unravel, and life, matter, and existence as we understand them become impossible. The fact that you can watch this video, that the sun shines, and that the atoms in your hand are holding together is all thanks to C being exactly what it is. It's a constant, for a very good reason. The world we woke up to, with its delayed lights and laggy internet, was just the gentle opening act to a play of cosmic annihilation. So the next time you flip a light switch and the room instantly brightens, take a moment to appreciate the steadfast, unchanging, and life-giving speed of light. What other fundamental constants do you think would be fascinating to change? What if gravity was weaker, or the charge of an electron was different? Let us know your most mind-bending what-if scenarios in the comments below. We'd love to explore them in a future video. Thanks for watching, and if you enjoyed this journey into speculative physics, be sure to subscribe for more deep dives into the mysteries of the cosmos.